Okay, we're going to look at how to do a rectangle coordinate proof doing two different methods. They're not the only methods, but they are two popular choices. First method we're going to look at is proving four right angles. You want to plot your parallel or your rectangle, so you know what you're looking at. And if you're aiming to do four right angles, you need to get that the lines are perpendicular. Perpendicular lines come from slopes. So I state my formula. Next, I need to get the slope of the four sides. You want to make sure here that you have the slopes of the sides and not the diagonals. And when I look at my numbers, -1, 1, -1, 1, I only have two different slopes, which is a good sign because opposite sides should be parallel. And also, my consecutive sides, -1 and +1, those are opposite reciprocals, which is what we're aiming for. So this is a good sign. Our slopes match. So now we need to summarize what these numbers tell us. Perpendicular lines have opposite reciprocal slopes. Our goal here is to get four right angles. So we need four sets of perpendiculars. AB is perpendicular to BC, BC to CD, CD to DA, and DA to AB, all four corners. Perpendicular lines meet to form right angles. So then I have ABC, BCD, CDA, DAB are right angles, all four. And if a quadrilateral has four right angles, then it's a rectangle. Therefore, ABCD is a rectangle. Pretty similar to our right triangle proof. Let's say we want to prove it's not a rectangle by showing there aren't right angles. We're going to do slope. I get the slope of AB and BC. Those are consecutive sides. 3/4 and 0 are not perpendicular. So I say perpendicular lines have opposite reciprocal slopes. AB is not perpendicular to BC. Perpendicular lines meet to form right angles. Well, they weren't perpendicular. So angle ABC is not a right angle. If a quadrilateral has four right angles, then it is a rectangle. Well, at least one of ours isn't. So we know ABCD is not a rectangle. Method 2 for proving something is a rectangle is going after our congruent diagonals. And if we're going to do congruent diagonals, we're going to go for the distance formula. And I am using the method of first proving that it is a parallelogram by showing opposite sides are congruent. So I've got the distance formula. I find the length of AB, BC, CD, AD, going all the way around my shape. Radical 18 matches radical 18, radical 50, radical 50. Opposite sides are congruent. This is good. That means it's a parallelogram. Now I attack my diagonals. AC and BD are both radical 68. Diagonals are congruent, makes my parallelogram a rectangle. So I have to summarize. Congruent segments are equal in measure. So AB matches CD, BC matches DA. Top, bottom, left, right. And the diagonals are congruent. If a quad has both pairs of opposite sides congruent, then it's a parallelogram. Therefore, ABCD is a parallelogram. And if a parallelogram has congruent diagonals, then the parallelogram is a rectangle. We showed this. We showed parallelogram. We showed congruent diagonals. So we can say ABCD is a rectangle. In my conclusions, I first explicitly stated that it was a parallelogram. That isn't necessary. On the bottom of this slide, it says, if a quad has both pairs of opposite sides congruent and congruent diagonals, then it is a rectangle. If you're going to use that wording, you can jump right to the conclusion that ABCD is a rectangle without telling me that it's a parallelogram first. Going back to this slide, I used distance to prove it's a parallelogram. Instead of four distances, you could have done four slopes here and shown it was a parallelogram because opposite sides were parallel, and then moved on to the congruent diagonals. So we have options besides those typed out in these templates. And let's say I want to prove it's not a rectangle by going after the diagonals. I do the distance formula. I get the length of one diagonal and the other. Those are clearly not the same. And I can wrap it up by saying congruent segments are equal. So AC is not congruent to BD. And if a parallelogram has congruent diagonals, then that parallelogram is a rectangle. My diagonals are not congruent, so it is not a rectangle. And we are all set with the not proof.